be the Powerflite unit out of that car I saw you driving around this morning, does it?
That it is, Tech. Roy and I just removed it from that car. I was just telling Roy that the owner reported a no-drive condition. What he meant was that when he put the selector into drive or reverse, the car wouldn't move. He had to wait a few seconds or longer before he could get underway.
But that didn't happen all the time, right?
You're right. It seemed to occur after the car had been standing for a while. After it got going, the transmission worked perfectly.
Fred and I checked the fluid level, the linkage adjustments, the band adjustment, and line and throttle pressures.
Yeah, Tech, and we also checked the regulator valve for freedom of movement by sliding the valve in and out of the side of the transmission. I reminded Roy that a valve body could warp due to improper torque of the pump housing attaching screws and cause the regulator valve to bind.
Reminded my foot. Fred beat me over the head with it. At any rate, Tech, everything checked out okay. Now Fred wants to inspect the front pump, but I don't know why.
Oh, there's a good reason for that. You tell him the story, Fred.
Well, Roy knows that the front pump supplies the oil pressure necessary to operate the servo and apply the kickdown band. He also knows the car won't move until the kickdown band is applied. So when the band fails to apply instantly, it's probably because the front pump lost its prime while the car was standing. That can happen if there's too much clearance between the face of the gear and pinion and the face of the housing.
Oh, I gotcha. You want to check the front pump to see if it has too much clearance at that point.
Exactly, my boy. So remove the pump housing with the gear and pinion, and do this carefully so you won't get something messed up.
Okay, mastermind. What'll I do next?
You'd better wash all the parts in solvent to get them good and clean. Once the parts are clean, place the hub of the housing on an even surface with the gear and pinion facing up.
Okay. Then what?
Well, there should be slightly more than 1 1/2 to slightly less than 3/1000 clearance between the face of the housing and the face of the gear and pinion.
Right. Use this parallel bar and feeler gauges or a dial indicator to check that clearance. Move the bar around and make the check in several places on the face.
Uh-oh. I get a shade more than 4/1000 clearance here, Fred.
I was afraid of that. Well, we'll have to dress off the face of the housing to get the clearance down to just under 3/1000.
That you can do easily, Roy. Just rub the housing face on crocus or very fine emery cloth placed on plate glass set on a surface plate or any surface you know is level.
Yeah, and check the face frequently to be sure the metal is being removed evenly and in just the right amount. When you're done, clean the parts carefully to remove all traces of metal particles.
Okay. But tell me, could anything else besides this clearance cause this same no-drive condition?
It sure could, Roy. A worn regulator valve body, for example. It always pays to check the front face of that valve body.
Good point. Sometimes that valve body face will be badly worn or scored by the gear and pinion. If that ever happens, you'll have to install a new body.
Okay, I'll remember that. Now, I suppose I can reinstall the front pump assembly.
Yeah, and torque the attaching screws evenly to 17 foot-pounds.
Well, that should take care of this job. You can install that transmission later, Roy. Right now, I'd like to get Tech's ideas on something else, and you might as well stick around.
Glad to help, Fred. What's the subject?
Power steering, Tech, when it chuckles or squeals. Once in a great while, I run across a case of pump seizure. In these cases, I repair the pump, or replace it if necessary. And when I install a repaired or a new pump, I make sure the pump cover screws are tightened to that new torque specification of 17 foot-pounds. Then I install the pump and the reservoir. After this installation, I check the pump pressure. If it is still too high, there may be a restriction in the pressure hose, and I install one of the new type hoses. Then I recheck the pressure. If there is still no change in pressure reading, I know that further checking of the hydraulic system is necessary. The trouble might be in the pressure relief valve or the back pressure valve.
That sounds okay to me, Fred. And Roy, in case you want further information on the new pressure hoses and how to check the pressure relief and back pressure valves, you'll find it in this reference book.
Okay, Tech, I'll look it over.
Good. Now, to get back to diagnosis, I know that loose front wheel bearings could cause power steering chuckle. So I check the bearings and adjust them if necessary.
Attaboy. You probably know that the chuckle could also be caused by a steering gear arm loose on the gear shaft.
How would you check for that? By feel?
That's how I'd do it. Just try to move the arm on the splines of the gear shaft. If there's movement, tighten the nut 100 to 120 foot-pounds.
Yeah, and don't guess. Use a torque wrench and be sure. Another cause of chuckle might be a gear shaft adjustment too loose.
Oh, yeah, and I'd like to run through the adjustment of the latest type gear.
Now, this might sound dumb, Fred, but what do you mean, latest gear?
Well, 2 types of gear shafts were used in 1955 production. The earlier type gear shaft uses a center tooth wider than the other 4. The later type has teeth of equal width. The later shaft also has a letter O stenciled on the steering arm end of the shaft.
If you can't see that letter, there's another way to identify the late type gear.
Yeah, the backlash remains the same at extreme turns as it is in the straight-ahead position. Backlash increases at extreme turns in the early type gear. And here's something I want you to remember, Roy. The backlash adjustment should be checked and readjusted on all new cars at the 1,000-mile inspection. That's because a part of the original adjustment is lost after a few hundred miles due to normal wearing in of the parts. When this occurs, backlash will show up.
Okay, Fred. I've got the picture on what causes backlash. Now, how do you take care of it?
First, start the engine. Backlash adjustment is always made with the power on, the linkage and steering arm removed, and a spare arm on the gear shaft. In addition, the steering wheel should be turned in the straight-ahead position. Loosen the adjusting screw lock nut and turn the adjusting screw out until there is some backlash. Then slowly turn the adjusting screw in until backlash is eliminated. Finally, slowly turn the adjusting screw in 3/4 of a turn from the no backlash position and tighten the lock nut. That puts a slight preload on the teeth so the adjustment will hold. Got that?
Yeah, that's clear enough. I won't have any trouble with that.
Good. Now let's see what we can do about a squealing noise in this unit.
Okay. When does that show up?
Well, the owner may report he hears the squeal any time when turning the steering wheel. That's usually due to a slipping belt. Check the generator drive belt first. It should have a 1/4 to a 1/2 inch deflection when you press it with your fingers, midway between the water pump and generator pulleys. Move the generator in or out to adjust the belt if necessary.
And when you're making the adjustment, don't guess. Use the generator belt tool and the torque wrench.
Then check the fan belt between the crankshaft and water pump pulleys. It should deflect from 1/4 to 1/2 an inch. You can loosen the idler pulley arm clamp and adjust the arm to get that deflection.
I can handle that belt tension all right.
Somebody better turn this record now, then we can talk about some other things I've picked up. On my various trips calling on dealers, Fred, I've noticed the procedures being used to correct certain carburetor conditions.
We had an interesting case a few days ago, Tech. An owner brought in a 55 Dodge with a Stromberg carburetor. Said it was stalling when hot and hard to start after the stall.
What were your ideas on the cause of that condition, Fred?
Well, Tech, the car was equipped with Powerflite, so I figured it might be dirt in the carburetor or an improper dash pot adjustment. And, of course, I knew that an engine idle speed set too low could cause the stalling. So could an improper adjustment of the idle mixture screws. In addition, I kept in mind the possibility of a low vacuum on the intake side of the fuel pump. Carburetor flooding due to a high float level and a fuel mixture too rich were also possible causes I figured I might have to check.
Well, you had the conditions sized up pretty good, Fred. Where did you begin?
With the idle speed setting, Tech. I warmed up the engine, and using the tachometer, I set idle speed at 475 to 500 RPM with the transmission in neutral. I also adjusted the idle mixture screws to get the highest engine RPM I could and still have a smooth idle. Those idle mixture screws, you know, should be 3/4 to 1 1/4 turns open. Then when I got my idle setting, I backed the mixture screws out an additional 1/8 of a turn. I've learned that this setting will compensate for higher road temperatures It also helps eliminate stalling.
Good. I found other fellows doing the same thing and getting good results.
Well, knowing the idle adjustment was okay, I figured I'd better check the dash pot adjustment.
What's that supposed to be, Fred?
A 1/16 to 3/32 of an inch clearance between the end of the dash pot plunger and the ear on the throttle lever when the throttle is closed and the plunger is pushed in, Roy. And that I didn't find. So I loosened the lock nut. Then I turned the dash pot assembly in its bracket to get the 1/16 clearance. Finally, I tightened the lock nut.
Did you stop there, Fred?
No, I knew a high float level would also cause stalling and hard hot starting after the stall. So I got out the float level gauge, and sure enough, the level was a little too high. By bending the lip of the float toward the float needle, I got the level back down to 3/16 inch from the top of the main body casting. Then I reassembled the carburetor using a new gasket. Out on the road, the Dodge ran like a dream. She started inside the 3 seconds, whether the engine was hot or cold. In fact, the engine ran so well, I knew the ignition timing, points, plugs, and engine compression were bound to be okay.
Sounds like a first-class job to me, Fred. And for Roy's benefit, there's more on carburetor conditions, such as vapor lock and what to do about them in the reference book.
Okay, fellas. I'll be sure to look that up.
Good. Now, I'd like to talk about another condition. We've had some reports that the fuel gauge isn't telling the right story occasionally. Some owners say the gauge shows empty when it's full, and vice versa. But they also say it doesn't happen all the time.
Before you get too far into fuel gauge service, why don't you explain how it operates first?
All right, good suggestion, Tech. The fuel gauge we use, Roy, is an electromagnetic type. It is made up of a panel unit and a tank unit connected by a single wire. The panel unit has 2 magnetic circuits, each of which has windings. One of the windings is internally grounded. It sets up a constant magnetic field, which pulls the needle toward empty when the ignition switch is turned on. The other winding, a variable magnetic field, is grounded through the tank unit. Inside the tank unit is a wire cone resistor with a sliding contact finger controlled by a float.
I see that, Fred. What's the resistor connected to?
It's connected to the panel unit and varies the current in one winding to give fuel level readings. The tank unit case is grounded, which completes the fuel gauge circuit.
I get it. When the float rises, the resistance decreases. That makes the variable magnetic field stronger than the constant field. So the pointer is pulled over to the full mark.
Right, my boy. So testing a gauge is mainly a matter of checking the circuit from ignition switch to the tank unit.
Tech's right, Roy. As a matter of fact, one common cause of fuel gauge trouble is a poor ground at either unit or inside the tank unit itself. So check out the circuit to be sure it's okay.
Suppose the circuit's okay and the system works all right some of the time, but at others it doesn't.
Well, the gauge needle might be sticking on the face or on the back of the dial. So you'd remove the gauge and straighten the needle carefully so it could go in either direction.
Better check the stops behind the dial of the gauge, too.
That's right. If those stops are bent, they'll prevent the needle from traveling the correct distance. You can bend them if necessary to properly control the movement of the needle.
By the way, suburban models use a 2-wire thermostatic fuel gauge. It works differently, and the adjustment is different. Maybe you ought to explain it to Roy.
Good idea, Tech. The thermostatic fuel gauge, Roy, has 2 wires connecting the panel and tank units. These wires connect with resistance windings designed to heat 2 thermostatic bimetal blades inside the panel unit. Next to the resistance wound blades are bimetal blades that act as temperature compensators and adjust for variations in temperature of the resistance windings. As the tank unit float rides the fuel level, the float arm moves a contact finger across a wedge-shaped resistance winding in the tank unit. This varies resistance and heat in the windings around the bimetal blades. The resistance-wound bimetal blades bend according to the amount of heat they receive. The lower ends of the bimetal blades move the gauge pointer.
I think I understand the connection, Fred. The wire from the screw terminal of the tank unit is wired to Terminal 1 on the panel unit. The bullet-type terminals of the two units are connected by a separate wire.
Exactly, Roy. And it's a check you might want to make sometime. If the bullet connection on the number 2 terminal of the panel unit is ever installed on the number 1 terminal, the gauge will register full when the tank is empty, and empty when the tank is full. So make sure the panel unit connections are at the proper terminals.
You can connect a new tank unit to the wires and test the panel gauge. Just turn the ignition on and work the float arm of the new tank unit.
Tech's right. Don't forget to allow about a minute or so after you turn the ignition on. That's needed to give the resistance windings time to warm up. If the panel unit registers all right with the new tank unit, check the original tank unit or the wiring. To test the wiring, disconnect the number 1 wire from the panel and tank terminals. Connect a test lamp with a 6 candle power bulb between the panel end of the wire and the AM terminal of the ammeter. If the bulb lights, the wire is grounded and you'll have to correct it. If the bulb doesn't light, ground the tank end of the number 1 wire. The test lamp should light and show that the circuit is okay. If it doesn't light, the circuit is open and the wire should be repaired or replaced. You test the number 2 wire the same way. If both wires are okay, replace the tank unit. Be sure to clean the tank and tank unit mounting surfaces in this case.
There may be cases where the gauge registers, but not quite accurately. In that case, you can remove and adjust it to give the correct readings. You'll find this procedure in the reference book.
Swell, Tech. I'll give it the once-over. I really appreciate all the service tips you and Fred covered today. You sure brought me up to date on a lot of different conditions.
Always glad to pass them along, Roy. Fred and I both know that keeping you posted on conditions as they come up makes everybody's job easier. What's more, it keeps our owners happier, too. And that's our business.